Hi, let's see how we can be able to make deletion of a node in a linked list. So, in general, the linked list has three different types of deletion. One is deleting the first node, and we have deleting the last node, and we will be having deleting at a particular position. And we will be giving the position like second position has to be deleted, and this is how we can be able to make deletion. So let's see what are all the functions that we are going to write for this. One is insert. So insert will be carrying an argument like 20, 30 that the data field we will be following it. And we will be having delete start, and we will be having delete last, and we will be also having a function. So deleting nth node. So at the particular node, so to take for example, the node has to be passed over here. The index value has to be passed over here. And we will be having calculate length. So to calculate the length of the nodes, number of nodes, we will be also having display function. So these are all some of the functions that we are going to build through. And yeah, so after this, so in a class, so take for example, I'm going to create a main class. So class main, and we have public static void main string args. Over here, I'm going to create a linked list L is equal to new linked list. Yeah, we have created this. After creating the main function, see, we have an extended package which has been created already. Like, so we need to create a separate class for this. So class linked list. So within which what we are going to do is we are going to create a node. So we are going to create a node. So the node generally consisting of two different fields. One is a data field and the other is the next field. So in general, whenever we have created a node, so it is of the data type int, char, float, primitive type of data type. And the next node that we will be creating now, so this one has to be in the data type of another node. Why? Because it will be carrying the address of another node. So the data type for this should be of type node itself. So one more node should be the data type here, 10, 20 now. So this is how integer it will be the data type. So let's create that over here. In before that, so before creating this, we are going to create the node named head. So head, we need to create it. Head. How we can be able to do that? Head in the sense, node head, we have created this. After this class node, yeah, we have two different types of fields. One is data field and the other is next field. We have created this. And for this class node we have created, we are going to create a constructor. So node integer x we have created, within which we have data is equal to x, and we have the next field has to be pointed to null. Why? Because whenever we were about to create a single node, so if we were creating a single node in the sense, we have to assign the next node as null initially. So that's why we have created it. And yeah, after creating, we are going to create some of the separate functions. So take for example, delete start. So before creating delete functions, we have to create insert function. So insert is nothing but with respect to the data which we will be passing, integer x. So whichever the value it might be, there's no issue. So we can be able to pass this insert a value like data. So after passing this value, we are going to return the return type as node, public node of insert. That's it. And we are going to create a new node. So whenever, take for example, if we were about to insert a new value here, we we will be assigning it to new node. So a new node will be getting created and within which the data field has to be inserted. So node new node is equal to Here how we will be creating it. New node of data. That's it. We have created. And after this, we are going to assign like new node dot next is equal to null. So such that the new node, so this one we are going to assign with the head. Why? Because so here we are going to insert the value new node. We will be having a linked list. Initially, the new nodes next will be null, right? So here that's why I have written this. What I'm going to do is I will be having the head here. This head has to be pointed over here. So that's why instead of null, I will be putting it as head. That's it. So new node next is equal to head. And then I'm going to rename the first node, new node as head. Why? Because we are going to rename it. So that's why. So head has to be assigned to new node is equal to new node. That's it. So after doing this, we are going to return the value. So return head. Okay. So after doing this, we are going to insert the first value on the very first thing. So public void delete start. So over here, deleting the value at the very first. If so, we have three different types of conditions for deleting a value at the first. So what it is we will be having delete start, so which is nothing but the inside the linked list. So we will be having different types, and the very first value has to be deleted. That we will be calling it as a delete start. So this value has to be firstly deleted. So if there is no value inside this, so head is equal to null, in the sense what we are going to do in the sense there is no deletion possible. So deletion not possible. That's it. After this, simply, so take for example, if there is a single node, if there is no node inside the linked list, deletion is not possible. At least there is a single node, it is the very first node. At least there are more than one nodes, like two nodes in the sense also, deletion is not possible. In these all cases, which value we will be deleting? Head, head, head node will be getting deleted. Why? Because head node is the very first node which we will be having, and we are going to delete that itself. That's it. So head dot next is equal to head. That's it. Simply head dot next is equal to head. So before writing this, we are going to give our print message. So deletion, so deleted head dot data. That's it. So this data has to be deleted, and we are going to make like head dot next has to be made as head. This is what we will be calling delete start, and we will be having public delete at the very last position. So public void delete last, which is nothing but we will be having the same condition. So if head is equal to null, so deletion is not possible. We will be writing the same. And also if any of the values after head, so take for example head dot next, in the sense if it is null, we are going to delete the head dot data. Why? Because if in some of the cases there will be two nodes, right? So take for example, if I have only one node is present and there is no more values are present in this, so this is what we will be calling like if head dot next is not equal to null, in the sense so this has to be deleted. Head dot data has to be deleted. So head dot next has to be made as head. That's it. So we are going to write it if head dot next is not equal to null, is null, in the sense what we are going to do. This is out of deleter of head dot data has to be deleted, which is nothing but head dot next has to be made as head is equal to head. That's it. So this is how we can be able to do that. And if more than one node is present, so in this case, so more than two nodes is present, more than one node is present. Take for example, I have two different types of nodes, two nodes here. So this is what we are going to do is we will be taking two different values. One is previous, and we will be having temp. So what previous will be assigned is null, simply null, and temp is nothing but head value. Okay, so we will be assigning it, and we are going to make a while loop which will be running until take for example temp value will be moving actually. So temp is a movable variable, it will be jumping from one node to another. So until temp reaches the last node, we will be stopping it. So temp dot next. So temp dot next will be null. Now, if it is the end of the linked list, so this will be null, right? So temp dot next not equal to null in the sense. So until this value will be getting running. So over here, what we are going to do is temp has to be assigned to previous, and temp dot next has to be assigned to temp. So this is what we are going to write it. And so simply we will be printing temp dot data. That is getting deleted. And after this, what we are going to do is see for cutting down, if it is the lastmost variable, this will be its previous. So why? Because temp is equal to temp dot next. Now, so it will be moving. We will be assigning temp to previous. So previous will be this. So previous dot next has to be null. So this will be getting deleted. So we will see this how we can do this. So take for example, previous is equal to null, and we will be having node temp is equal to head. That's it. So we have created and while of temp dot next not equal to null in the sense here until this what we are going to do is previous is equal to temp, and we will be having temp is equal to temp dot next. So is out of we are going to delete. Why? Because we will be just converting all these things. See, node has to be made as null firstly, and temp as head, and temp dot next not equal to null. Previous is equal to temp is equal to temp dot next, and we are going to print the temp dot values data. So which is getting deleted plus temp dot data we will be which we will be deleting, and then we are going to make previous dot next as null. That's it. What does this previous dot next is equal to null in the sense after all these while iterations, what will happen in the sense, take for example, I have consecutively four number of nodes in a linked list. So after all it is getting iterated, this will be my temp and this will be my previous. So see it carefully. See what we are going to do is this value is getting deleted. So that's why I am printing temp dot data. And after this, see previous dot next is equal to null, which is nothing but previous next is temp, right? This will be made as null, which is nothing but it will be getting deleted. So the node which is at the last will be getting deleted simply. And deleting a node which is at the particular position, how we can do that in the sense public void delete nth node. So delete n node in the sense. So here I'm going to pass an argument integer n, and here I'm going to use two different types of function. One is calculate length. So calculate length for calculating the number of nodes in it. We will be also creating display as well. So these are the two different functions I'm going to create. So integer length is equal to calculate length of head. why we are taking it from the head in the sense we know that the initial node is head, so we can directly count it, right? Head means we can count it with the help of length itself. So that's why we are doing it head. And then if n is less than 1, which is nothing but 0. So if there is nothing in the sense, deletion is not even itself is possible. That's why. Or if n is greater than the actual size. So take for example, the actual length is itself 3. I'm going to delete the fifth element in the sense it is not even possible. So that's why which are all the lengths which is greater than that of lengths, we will be just simply writing delete, no deletion. That's it. After this, else condition. So else here, if n is equal to 1 in the sense, so here we will be passing deleted of which node. So head's data, head dot data will be getting deleted, and this head will be moving actually. So how we can be able to move head dot next has to be assigned to head. That's it. Head is equal to head dot next. This is how this particular node will be getting deleted. If only one node is present, which is nothing but the same phenomenon where we have used it for a very first node. So if there is only one node is present in the sense, that will be getting deleted for delete last as well. So another the next node will be null because there is no node is present. So we will be pointing the head to this. That's it. So this is what we will be doing over here. Or else, so even if this condition is not at all possible, so what we will be doing is we will be creating two different types of variables. One is a temp variable. We will be creating a temp variable, and also we will be creating a previous variable. So which we will be running, the while loop will be running until the n value is set to particular number. So here what we are going to do is the same phenomenon that we have used previously, which is nothing but previous has to be assigned to temp. Temp dot next has to be assigned to temp. That's it. So we will be assigning and getting the value. And after this, what we are going to do is see, we will be having the number of nodes. So take for example, I am going to delete the third element, third most node in the sense. So this will be made as temp and this will be my previous. So temps next. So what is temps next? This one, right? So this one has to be assigned to previous next. That's it. So that's how it will be getting deleted now. So that's what we will be writing here. Temps next. What is temps next? This one, right? Temps next has to be assigned to previous next. That's it simply. And we are going to mention temp.data has been deleted with the help of system.out.println. Okay, so this is the thing that we are going to do over here. Let's do the same. So here we will be creating two nodes. Node temp is equal to head, and we will be having node previous is equal to null. While n is greater than that of 0 in the sense, what we are going to do in the previous is equal to temp. So we are going to write the same here as a code. That's it. So temp is equal to temp dot next. That's it. So we have data. And after this, we are going to assign previous next to temp dot next. So previous dot next has to be assigned to temp dot next. And we are going to print it. So system.out.println deleted plus temp.data. So this is how the particular data will be getting deleted. And how we can be able to create the calculate length. See, this function that we have created, we need to implement that, which is nothing but we will be having the number of lengths. So take for example, we will be having the number of nodes. Calculate length in the sense we will be having initially length value as 0 and we will be having head. While iterating the head, so the head has to be assigned to temp. So temp dot next not equal to null. Until that we will be iterating and we will be incrementing this length. So length plus plus. So this is how we will be incrementing. While of temp not equal to null, we will be iterating until that. So until then we will be just incrementing. So length plus plus, and we will be having temp value has to be assigned to temps next. That's it. So we will be just convert this into code. How we can be able to do this? We have calculate length. So public, which will be returning an integer, calculate length, and we will be passing node temporary. So temp as a head. So head we will be having previously. See, calculate length has head as an argument. So initially that head we will be converting it into temp. So here and then we are going to assign length is equal to 0 and we have a while loop. So while of temp dot next is not equal to null. So under this this will be running or temp is not equal to null is also fine, no issues. So temp not equal to null. Here I'm going to increment length plus plus and we will be having temp value which will be assigned to temp dot next. Temp is equal to temp dot next. That's it. And we will be having only one more function which is nothing but a display function. For that, we will be having public void display. Display function is very simple. We will be having see here the return type is int. We need to return the same. So return length. That's why it is showing it in red. So return length. And within the display function, for that we will be creating a node temp. So node temp is equal to head. That's it. So head is also fine. We are going to iterate it. After this, while of node temp is not equal to null. So simply like take the same thing, copy. Why? Because both are iterations, right? We can take the same instead of incrementing simply, we are going to print the temps dot data. Temp dot data has to be printed plus space. It doesn't need an ln function. That's it. So these are all some of the basic functions that we will be creating. And within this linked list, let's create the operations that we are going to perform. So firstly, we are going to insert something. So dot insert. Yeah. So here with insert, we are going to insert some of the values as well. So let's take like 6, 5, 4, 3, 2, and we have 1. Yeah. We will display all these values lvel.display and let's delete the value at the first. So delete first, delete start, otherwise delete start, and let's display the same ll.display. And we have delete last ll.display. And we have a delete at a particular position. So delete nth node with respect to 3. Take for example, if it is 3 in the sense, we are going to display the same. LL dot display. That's it. So we can be able to delete all those types of elements. And let's try to run this. We have the output as well. So let's try to dry run this R code. Initially, we were inserting all the elements as these are insert start. So we have 6, 5, 4, 3, 2, and 1. Why? Because inserting at the start. So 6 insert start. So at this line will be printing 5. This line will be inserting 4 and 3, 2, 1. So likewise it will be getting inserted and we will be getting displayed. So this is what is the first print statement. And after this delete start. So which is nothing but 1 will be getting deleted. So such that what will be the output? 2, 3, 4, 5 and 6. So this we will be displaying after delete start. And we have delete last. So which is nothing but last element will be getting deleted. So 2, 3, 4, 5 will be getting printed on the third line. And we will be having deleting at the particular nth node. So which is nothing but the third in the sense. What is the third position over here? It's 4, right? So 4 will be getting deleted and our output will be 2, 3 and 5. This is the third position. So this will be getting deleted. Let's see the output. See 1, 2, 3, 4, 5, 6. 2, 3, 4, 5, 6 and we have 2, 3, 4, 5 and the third element will be getting deleted, that is 4 will be getting deleted and we have 2, 3 and 5. So this is how we can be able to make deletion at the start, last at a particular position. Thank you.